is when you take an object, example, this face, and you rotate it by a certain amount of degrees. For example, you can rotate it by 90 degrees. You can rotate it by 180 degrees. You can rotate it by 270 degrees. And example, 360 degrees. Okay, now you can also call it a quarter turn. That 90 degrees is a quarter turn, because a quarter is 360. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, now to make it more confusing, they have clockwise, tuk, 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 and anti-clockwise. Tuk, 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 tuk. So if it's say 180 clockwise, you have to go like that. So you rotate it along the clock line, like tick, 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 and you say it in the middle. If you want 270, it's the same. But if you go 360 from the anti-clockwise, it go tick, 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 all the way around, one full turn, 360 degrees from the right. Thank you. That was my explanation of how rotation works. Reflection is awesome. You use it in maths lots. Okay, I'm show you how to do reflection in ordinary ways. Here we have a smiley face, just like the one in the previous slide. Okay, to reflect, you need a reflection line. Reflection line is a imaginary line. I've drawn it here. And just say, pretend there's a mirror there. And if you draw an object on one side, you reflect it, it will be on the other side. So it's sort of quite cool, very useful in maths. See, there's the line there and it reflects. So basically, if you fold the paper over, it will be the same if you fold it on the reflection line, see there. And if you fold it, they should all be in the same place. You see? Can you see through? Look, they're both in the same place. Because if you've done it with a vivid, the ink doesn't dry. So you can close it, and then you can see the smiley face on the other side of drawing it, and that is an automatic reflection. Here we are again, except we're outside. Let's go pick an orange off a tree. Oh look, we found one. Orange. I'll show you how to do translation. Here's my automatic whiteboard. Translation is when you take an object, like an orange I picked off the tree, and you move it across however many ways. 1, 2, 3, 4, maybe 2 up. It does not matter. The one rule for translation, you never distort the orange. So you never change what it looks like, because you're only changing the position that it's already in. So you do not enlarge it, you do not reflect it, you do not rotate it, you keep it in the same, but you move it across more. So that's how you translate an object like an orange. I'm going to eat this orange right now. See you later. Good morning and welcome to another last section of our video. Show you how to do everything complex math. Now we're outside in the midst of mountains. Kimberly Dean's to my side. We look at the tree. See, look at the tree. Look at the tree. Okay, now if you want to take this one from the further back in the video, maybe 2 minutes, then that's the same one. We reuse, reduce, recycle. But take this and want to make it bigger. Don't like small things. We want big things. So we can go like this. Boom! We enlarge this object into this guy. Haven't used him yet, he's new. But if you want to get from that to that, you have to enlarge. So if you want to enlarge something from there, you have to then make it like this. Have one there, and if you're enlarging it by scale factor again of 1, then it's like that. If you do it to 3, then it will be a bigger one, sort of like that. If you want to make it bigger, you have to use 7 more to make it right. That's how you enlarge an object. I'm going to reuse these. And basically, I hope I showed you how to enlarge things. See you later.